Hi, we're going to continue talking about script language here. Here's an example here. For instance, a script that installs software can check free disk space and abort the installation if sufficient disk space is available here. It's a very simple script language here. You want to install some kind of a new software and you have a script language. They will check whether you have enough disk space. If you don't have enough disk space in first place, then why bother try to install? It will fail here, that's for sure here. So that's a script language here. And it happens a lot here. Sometimes you try to install something, the computer just tell you, hey, you don't have enough space for that. So that's a script language here. In here, it's a modified version of a different ones for employer user interface here. You have an echo here. Echo here is want you to enter your username here. Then they're going to read your username here. Then you're going to have some other name here, and share name here, share name, and change on here, change mode here. 775. You need to understand what 775 here. See, you have 124. That's 7. 124. That's 7 here, and that's 14 here is 5 here. So based on that, you will know who you or your group members or everybody else here can read or run or execute the program. That's a change mode here. And the one special variable is $? Here. So exit here, you're going to exit the status here. Meaning, say for instance, using the previous example, you're trying to install a new software. Then you don't have enough disk space. The program will go to $? Here, exit here. And using the conditional here, if then else case of, that's typically in say if here. If something happened, if then else here, to do this one. For example here, if files exist and it's a regular file here, then you're going to do, then that's true here, you're going to do something. Otherwise, you're going to do something else here. That's the if then else command. If something, the condition is fulfilled here, then you're going to do something else. This one here, because you already exit here, then there's no more else. Else, what I'm going to do here? No. Yeah, thinking about the same example here. If you don't have enough disk space, we're going to tell you, hey, there's no enough disk space. Then we exit this script language. There's no reason to continue. And in here, if test and something happen, you can also use a command return variable, like if something, then something here. If that's a pair here. That's beginning of if, and the fee here is the ending of if here. Beginning of the if check, ending of if check here. Yeah, this one here. So for the if command here, you can use like if, then do something here. You can also expand to have if that's true, then you do something here. Else, that's false here, you do something else here. So if then else here. If then else or if then, that's two options for the if conditional operation. Now case of here, as I mentioned, if then else, case of here. So you have more than two options here, true or not true here, then you have more than that, like 3 or more. Then use the case word in pattern 1, pattern 2. You see here, ... If you only have 2, you still can use if, then. And if you have more than that, it's better use case here. Case 1, 2, 3. Now, or more than 3 here, then you're going to do something here. Will it still work here if you have like 5 here? Can you still use if then else? You can. There'll be nesting here. If something, then if this guy here, then do something. Otherwise, check if that is 2 here, then do something. Yes. Otherwise, then not. Then check 3, then do something. And nesting here, it will work here, but it's a bad programming skill here. It's difficult for you or any other to follow to troubleshoot here. So more than 2 conditions here, you are going to use a case of. So that's only the syntax of the scripting language here. Case, something, in something, pattern, something, and yeah, in here. Using loops here. Loop here is if we have if then else, we have a case of, we have loop in here. So like for instance, I'm going to calculate a class with 25 students. So I can see each student's average added up, then divided by 25. I come up with a class average. That will be a loop in here. So for, I'm going to say for that one here, for student number here is less than 25. So I'm going to say, okay, right now it's number 1 here. Initial is 1, the first student. Then I'm going to add that student's average. Then plus 1. After I do that, I plus 1 here. Then I have 2. So the second student, I'm still going to include the student's average and add them up here. Then I add 1 here, going to be 3. Then I come back, loop in here, come back here, for loop here. Then I come back here for 3 here, 3 to the check, still less than 25. And once I keep doing this looping until I get 25, I have 25 students, I do 25 times, now it's less than 25, no, it's equal to 25. Then I have finished. I have finished collecting all the students from 1 to 25, all their class average. What I'm going to do next, I'm going to divide it by my number of students, which is 25. After division, I get an average, class average. So there's the for loop here, if and else, case of for loop here. It's just like any other programming language. And you're going to list here. That's wildcard here. So anything else will work here. So in here, and while loop here. So you have for loop here and while loop here. So that's a different, 2 different type. The while something, while some condition here. Yeah, that's a different way here. The until loop is similar to form here, but it continues execution for as long as condition is false. That is, until the conditions becomes true here. Well, yeah, that's using a negative here, like a negative here. So I'm going to say while it's not the end of last student, do this, or keep doing. While still not the end, while still not the last student, keep doing that here. So while and for loop here, it's pretty much similar with a different logic here. So they said that another type of loop is the while loop here, which executes for as long as its condition is true. So as long as it's true, they're going to keep doing it here. Okay, so let's see how they explain the for loop here. They are talking about yeah, they don't really talking about for loop, the difference between this one and that one here. That's fine here. So you have for loop and while loop here, 2 different based on the different logic. Say this one here, using the function here, they have my function command here, the keyword here, function here. So they can use my function here. Function is a part of script here. Yeah, just like a built-in here. The purpose of a script is to have many built-in functions here. Then you don't have to rewrite it here. It's pretty much thinking like subroutine idea or object-oriented object idea here. They don't want you to read it. They don't want you to keep doing that to preventing the errors you're going to introduce here. So it's a subtask here, and it can be called a function here. So this function that keep going to do the same stuff, you're going to use it here. Yeah, they have give example. If your script need to perform a half of dozen distinct computations, you can play each computation yourself. Yeah. So function here, thinking about like a subroutine here. A script demonstrates the use of function here. So they're going to do something here and do a function check here. So yeah, this is a check function here. You're going to use it here. So since you're going to use it here, you're going to call the function here. And the function here, you're going to write a different script language in other places here. So in this case here, if you have the function script here works fine, then whichever program call this function, it's going to be always looks fine here. Otherwise, you're going to rewrite the function here. It's not a good idea. This is a programming language reuse concept here. You need to reuse whatever you can to reduce the errors you're going to introduce here. We are only human here. We always introduce errors here to our programs here. It's not looking for perfection here. It's looking for reduce the number of errors here. And later on, via testing here, you can get rid of all of the error here. Okay. So they tell you if the script language detect an error, or if your user select an option to terminate, you can exit here. Yeah. This one here is you want to prevent him to have infinitive loop here. If you don't do that here, if you don't mess up in here, your program here may circling around and around, over and over, around and around. They can never go out here. It's called infinitive loop here. You don't have to do this right here. Then what does that mean? It means your program is not working. It's not going to come back here to tell you, hey, the result here, okay, I cannot do it, or pass or fail. You don't have a pass, you don't have a fail here, you have infinitive loop here. You need to get rid of here. Yeah, that's basically the programming language exit here. Yeah, you need to have an exit here. And let me show you something maybe a little bit difficult. So we'll see if we can learn a little bit about how to do it. It's 5 minutes here. See how long can we go here.
Well, hello everybody. In this video series, I'm going to go over how I implement a scripting language inside of C++. With this scripting language, I can do a number of things. I can evaluate expressions, evaluate strings, write functions, and call them in series with my programs. So, for example, if I wanted to, while I'm writing a program, I can call my script to do certain things instead of having to hard code it into my C++ application. Anyways, let's get into the actual demonstration of what my scripting language can do. The parser is used to compile the expression into bytecode. So the parser converts expressions like this, determines their meaning, and writes the equivalent instructions for my script. And the script over here holds the actual set of instructions to be executed later. So here I'm calling my expression to be evaluated, and I'm basically saying the parser, I want you to evaluate this expression and store the instructions into the script instance over here. So it's going to say y is equal to x squared plus 4 plus 32. You would expect this expression here to be evaluated first, or this one can be evaluated first as well, but it just so happens that this will be executed first, followed by here, and then the two results will be added together and finally assigned to y. So if I go ahead and run this program, I can demonstrate what's going on. So this is kind of the process that it's going through, and it's a recursive call to compile all this code into instructions. So we're going to come over here and extract these two content, the content of this parentheses, evaluate them, recursive call, and then replace the value that was evaluated with RST. RST is basically a placeholder that I've defined. It's a convention that I've defined to kind of make the understanding of this process simpler for myself. It's going to evaluate these three tokens, and after it's done evaluating them, RST is going to stand in place of this. And then finally, the two results are added together and assigned to the variable y. So in terms of bytecode, so 4 plus 32, we push the two values together and we add them. And then next we do x and 2 and do an exponent of those two variables. and then we add everything together and finally store the value in y. I haven't written the execution parts of I still just have the compilation process. Next, we'll be implementing the execution component of our script. But real quick, I want to demonstrate that I can also write functions for my script by saying function equation, and let's say we're going to take a variable x, and then we're going to say compile, then we're going to return. As you can see, I do some typos. Compile again, still problems. Alright. Okay, finally. Alright, let's run it. So now what it does is it says, okay, we're defining a function called equation, and we're doing argument check. This is what this stands for, argument check for 1. So when this function is being executed, which I have not implemented yet, it'll check what I will implement as the stack. It'll check the stack to make sure the stack has at least a 1 value on the stack. Otherwise, it's going to tell the user, hey, there's a problem. And so that's what this does. And then at the end of the function, there's a return operation, and this returns to whatever called this function. So that's what's kind of going on. So yeah, so this is going to be a video series, and I'm going to go from compiling my bytecode to actually executing my bytecode. And so yeah, please leave a comment below and subscribe and rate this video. That really helps me out.
Yeah, this is a very, very useful video to show you the programming language, how to write a script language here. Yeah, it's a good demo here. If you want to, you need to have Linux here. You actually write a couple of script here. That's how you learn here. If you have taken any programming language like C++, it's going to be easy for you to learn how to write a script language. If you have not taken any programming language before, yeah, it will be a little bit difficult for you to, but you still can handle. Script language here is easier than a C++ language here. And Python here, or Perl, Perl is came long time ago and still used, and Python is a new one, many people using. That's a script language here. It's important in the industry. You want to learn something, it's useful to find a job here, or going to be used in the workplace here. And script language wise here, Perl is one here, and another one is Python here. That's all I would like to share with you for this lecture.